Hello to all my viewers. This is Dr. Dhaval Maheta, and today we'll understand how to run support vector machine in Orange. Support vector machine is a powerful and a widely used machine learning algorithm that is used for both classification and regression problems. Support vector machine is a discriminative algorithm that separates the data points into different classes by constructing a hyperplane. You can see here, or a set of hyperplanes in a high dimensional space. SVM works by finding the optimal hyperplane that maximizes the margin between the two classes. So here, the objective is to maximize the margin, with the margin being the distance between the hyperplane and the closest data point from each class. So let's say this is a point for this class and this is the point for this class. These are known as support vectors. The objective is to maximize the margin. After running support vector machine, it's necessary that we evaluate. We evaluate our results. This is done with the help of confusion matrix. So on y-axis, we are having true label. On x-axis, the predicted label. True label means the actual observation. X-axis, that is the prediction done according to the model. 50 are such cases in which the person was having the COVID and the prediction done by the model is also correct. 114 are such cases in which the person was normal and the prediction done by the model is also correct that the person is normal. So 140 plus 50, 164 are such cases which are correctly classified. Let's talk about this one. Person is normal according to the model, the person is having a COVID. 6 such cases are there. The person is having a COVID, but according to the model, the person is normal. So 22 such cases are there. 22 plus 6, 28 cases are misclassified. Cross-validation. Cross-validation is a technique for validating the model efficiency by training it on the subset of input data and testing on previously unseen subset of the input data. We can also say it is a technique to check how a statistical model generalizes to an independent data set. Let's understand this. All data divided into two parts, training and testing. The green one is training, blue one is testing. So folds are created. So here 5 folds are there. It means that if we are having 100 instances, in each fold there are 20 instances, 20 observations. In first iteration, fold 1 becomes a testing data and remaining are the training data. In split 2 or iteration 2, fold 2 is a testing data, remaining are training data. This continues for 5 iterations till we get the optimal parameters. So now let's see how we can do this in Orange. The first widget which will activate is a file widget. Click on it. Double click on it. Browse. Activate Heart1 dataset. Press open. Just see the names of the variable in the first column: age, gender, chest pain type, and its type and its role. I will request all my viewers to kindly refer my previous videos to understand the flow of this tutorial. Now, just scroll and just see the heart disease, which is our target variable. It is always necessary to specify your target variable. In case if it is not specified, just click here, click on target and press apply. Now close this. Next thing which you have to do is activate the data sampler. Click here. Connect file with the data sampler. Double click on it. Sampling type which is available is fixed proportion of the data. 70% goes for training, 30% for testing. Fixed sample size can also be extracted. That is 100 observations, 200 observations. Cross validation. We already discussed about this part. Five folds. So here 10 folds are there. It means 9 goes for training, 1 for testing. Bootstrapping is also available. Now close this. Activate model, which is support vector machine. Click here. Next, you will have to evaluate it. This is in test and score. Connect data sampler with test and score. Support vector machine with test and score. Done. Double click on it. So area under the curve is ready. Classification accuracy is there, F1 precision, and so it depends completely on the researcher, that what is the objective, to maximize F1, to maximize precision, or to maximize recall. Cross validation can be done from here. Random sampling, leave one out, that can also be activated. Now close this and activate confusion matrix, which is available in evaluate. Click here, connect it. Now double click on it. Just see. So it's giving me percentage. You click on number of instances from here. Okay, 785 are such cases in which the actual observation is that the person is not having the heart disease. The prediction done by the model is that the person is not having a heart disease. So 785 is correctly classified. No, no. Here, the person is having a heart disease. Prediction done by the model is also correct. So 1129 are such cases. So actual yes, predicted yes, this is desirable. Actual no, predicted no, this is also desirable. What is not desirable? Actual yes, predicted no. So the person was having the heart disease. Prediction done by the model is no. Here, actual no, the person is not having a heart disease. Prediction done by the model is yes. So 121 plus 155 are misclassified cases. 785 plus 1129 are correctly classified cases. Now activate ROC curve. Test and score. Double click on it. Make sure the target is yes. So on y-axis we are having sensitivity, on x-axis 1 minus specificity. Under the ideal scenario, this curve, this one, the green one, should be nearer to the top left corner. This should be nearer to top left corner. Or just see the trajectory. It should be nearer to y-axis and x-axis, like this way. It should be nearer to this y and x. Now close this, activate the performance curve, connect test and score with the performance score, double click on it, make sure target is yes. So the performance curve shows the curves for analyzing the proportion of true positive data instances in relation to the classifier's threshold, or the number of instances that we classify as positive. You can get cumulative gains from here. Precision recall. Okay. Now let's create some space here. Bring support vector machine here. Data sampler here. Now go in evaluate, activate the prediction. I'll explain this. What's the concept? Double click on the data sampler. 70% is for the training purpose. Remaining 30% is for testing. So now the 30% data will be entering into the predictions, and the algorithm will also enter into the predictions. But before that, you will have to double click on it to specify that run the algorithm only on the remaining data. Click here, click OK. Now double click on it and just see the prediction done according to the model. Here is it, heart disease. Now close this. The next thing is disconnect this. Take the data sampler on the top. Support vector machine here. Prediction, keep as it is. Now we will include some more algorithms here. So for the comparison purpose, let's include logistic regression 1. Let's include the random forest 2, and connect this. Test and score. Now double click on it and just see which is the best algorithm according to the area under the curve. So SVM is best at present. Classification accuracy is also good of SVM. So you can compare it. Go in the confusion matrix. For SVM 785 plus 1129. For logistic regression 812 plus 1092. Random forest 783 1117. Just try to find out how many correctly classified cases are there, just for comparison. Misclassification should be less. ROC analysis, you can see one by one. So green is more nearer to this top left corner, which is the SVM algorithm. Performance curve. So the performance of the green one is much better. That is support vector machine. Close it. Now what you will do, you will connect file with the support vector machine, file with the logistic regression, file with the random forest, and activate one more widget, the file widget. Click here. Double click on it. Browse. There are two data sets. Heart1, the original data set on which the training was given to the model. That is the data set used for training purpose. Now this is Heart1 test. A completely new instances, 10 new instances which were never feeded in the model. Press open. So you can see the name of the variable, but the interesting thing is at the bottom. Heart disease, the target variable is not there. We want that the model predicts it. Close it. Now connect this file with the predictions, logistic regression with the predictions, random forest with the predictions. Double click on it and just see the prediction according to the support vector machine, logistic regression, and random forest. Okay. So this was all about how to run support vector machine in Orange. For more videos on data mining using Orange, kindly subscribe to my channel. You can also refer my playlist in which I have uploaded videos on data science, machine learning, and artificial intelligence. Please don't forget to like and share my videos. You can also follow me on different social medias, link given in the description box.